Welcome everyone to the Hobby and Tech Warrior, where we delve deeper into the little secrets hidden within the hobbies that preoccupy us. J4 here, and in this video, I have something airsoft for you guys. Specifically, I will be repairing an ICS M4 that was used as a donor gun to restore another AEG. The restoration does cover a lot of details, so instead of putting it all into one video like I did in my previous upload regarding the Tokyo Marui G36C repair, I decided that I will segment the process to make the flow of information more easily digestible. If you're looking for a reference on rebuilding AEGs, this series is something you'll want to look at. To start off this restoration, I will be focusing on the process of shimming the gears and setting up the motor height. The other steps will be linked in the description below, or at the end of this video as they become available. So why even restore this ICS M4 AEG? With its split gearbox design and functioning forward assist that works as a spring decompressor, this may be the best M4 AEG for airsoft techies like me to build out a test platform, and maybe even something you will want to consider adding to your own arsenal. The great advantage of the ICS M4 platform is in its split gearbox design that separates the upper and lower segments, allowing you to isolate the work to the upper compression components or lower powertrain independently. The split gearbox also fits perfectly in the M4's two-part receiver layout, allowing the traditional disassembly process to separate the gearbox as well. In addition, the forward assist works as a functioning spring decompressor by engaging the anti-reversal latch through an extended lever. More modern iterations has since transferred the task of this feature to the selector plate, which releases the action every time you set the selector switch to safe. This is ingenious, but if you ask me, I prefer that the mock forward assist on the old design is functional beyond aesthetic. I will now focus on the bottom half of the gearbox. This half of the gearbox contains the gear train that is in charge of transmitting power from the motor onto the piston and mainspring in the upper gearbox. The electrical circuit for the trigger also runs through here, but we will focus on setting up the gears for now. The gear train is composed of the gear set and motor's pinion gear. As the name implies, most of the gears are purchased as a set, with the same pitch and varying characteristics. There are exceptions, but sets will typically include the bevel gear, spur gear, and sector gear. The bevel gear converts the angle of the motor's rotational force, directing the work in line with the rest of the gears. The spur gear, with its wider radii, acts as a torque multiplier for the bevel gear, converting the smaller, quicker rotations from the motor and bevel to longer rotations with greater torque. The spur gear transmits this torque to the sector gear. The sector gear has teeth along a section of its circumference. Its job is to transfer the work onto the piston and mainspring on the upper gearbox, where the first tooth acts as a pickup tooth to draw the piston, and the last tooth acting as the release. For this mechanism, stability and smoothness of operation becomes very important. There is no way to enforce a universal one-size-fits-all measurement, because there are many combinations possible in the airsoft aftermarket world. Therefore, gear sets are manufactured to fit wide tolerances through shimming. Shimming is the process of using spacers to fine-tune the placement of each gear at the most optimal position for the best balance in smoothness of operation, high power transmission, and clearance. The goal of the shimming process is to minimize the side-to-side play of the gear set and provide stability as their axles ride the bushings. If left excessively loose, the gears may snag and rub against other metal parts as they spin, leading to drag in the power delivery or even breakage. We want a minimum of at least 50% contact area between the face of the gear teeth. More than that, and we get better transmission, but with a higher risk of rubbing the gear faces against each other. Lessening contact area gets us more clearance, but risks chipping the gear teeth due to lack of support on the load. I always start a shim job with the rear of a spur gear, which sets the reference point for the other gears. Ideally, You want the spur gear to sit low enough against the gearbox shell to prevent rubbing against the sector and bevel gears, and high enough to avoid snags on bushings and other gearbox material. The bushings usually add a bit of initial height to the gears, but the 6mm solid bushings I used here are relatively low profile, which allowed me to start off with a 0.5mm thick shim. After the shim has been placed, I test the effectiveness of the clearance by closing up the gearbox and turning the gears by hand. Initially, the spur gear still hit the bushings when turned, but closing the lower gearbox shell removed any axial play and revealed that the spacing was just right, just enough to clear the bushings, and as low as I could get it. Some gearboxes exhibit a change in drag characteristics from when the other half of the gearbox shell and fasteners are installed. That wasn't the case here, and the spur gear continued to spin freely with or without the fasteners installed. Now that the bottom of the spur gear has been shimmed, the top needs to be shimmed as well to reduce the gap and play against the top half of the lower gearbox shell. I continue with thick shims and then test for spin. If the last shim is too tight and begins to drag on the spur gear, it will prevent it from freewheeling. If that is the case, I will then remove and replace the last shim with a thinner one and try again. Eventually, you will strike a balance between play and freewheeling. You can again close up the lower gearbox shell and install the fasteners to make sure the clearances are just right. Shimming the bevel gear requires that you first set the motor height. As the motor is pushed into the gearbox, the pinion gear on the motor interfaces with the bevel gear. As the contact between them increases, the pinion gear will displace the bevel gear along the axis of its axle, pushing it towards the gearbox shell. In some cases, it is possible to drive the motor too far in, which will bottom out the bevel gear against the bushing or shims, causing the gear to drag, or worse, deform. To initiate the test fitting phase, the top half of the gearbox shell is used, with the top face of the bevel gear installed in its position on the bushing. The pistol grip that acts as the motor's housing is attached together with the motor itself and the grip's end cap. Adjusting the motor height requires that you access the screw that controls the depth of the motor in the grip. On the ICS M4S system, you will require a flathead screwdriver to remove a screw cap which reveals the screw plate that adjusts the depth. Other manufacturers may use a disc-shaped motor plate which was not implemented or required here. First, unscrew the screw plate to lower the motor height until the motor's bell housing is touching the grip's end cap. Install the motor into the grip and seal the end with the end cap. Using a micro flathead screwdriver, go ahead and feel for the bevel gear's room for play as you adjust the motor height. Since only half of the gearbox shell is present here, you'll get a view of how well the pinion and bevel gear are interfacing. Adjust the motor height with the goal of having the base of the pinion gear teeth sit flush with the bevel gear, while preventing the bevel gear from bottoming out. The test fitting revealed that this specific combination of parts that I had on hand would bottom out without the base of the pinion gear teeth sitting flush with the bevel gear teeth. Since both sides of the gears must be shimmed, I went ahead and backed out the motor enough so I could use a 0.1mm shim on the top of the bevel gear, which was the thinnest shim I had on hand. I then adjusted the motor height for maximum contact, while trying to avoid crushing the shim with the bevel gear. In this case, the pitch of the teeth on the pinion gear was different from the bevel gear, and prevented them from meshing all the way. This stopped the motor height adjustment just about 90% of being flush with the bevel gear. This should still be in the realm of very sufficient contact area required to effectively transmit the power from the motor onto the gears reliably. But we'll see how they hold up over time, and come back to see how they do at a later date. Now that the motor height has been set up, and the top face of the bevel gear has been shimmed, the other side of the gear axle needs to be filled to stabilize the gear. Following the same process on the spur gear, add thick shims to fill up space, and swap out the last shim for a thinner one if it gets too tight. You can also verify your shim job by closing up the gearbox shell, adding fasteners, and checking if the gears still spin freely. After shimming the bevel gear and checking the spin, the spur gear developed a sound and vibration referred to as chatter. This indicates an instability against the bevel gear and revealed the need to add more shims to the spur gear. I did just that, and the sound went away. This goes to show that you should verify your shim job as you add on gears. Now that the spur and bevel gear are shimmed, only the sector gear remains. Before that, I take the cutoff lever and screw it down in its place on the gearbox. This would be the boss screw hole behind the trigger, a protrusion that serves as an axle the cutoff lever rotates around. The sector gear has a cam on the back that actuates the cutoff lever with every full rotation. And it is this set of actions that initiate the semi-automatic feature on Airsoft AEGs. Back to shimming the sector gear. Shimming the sector gear is much like shimming the spur gear, with one added consideration. That is, how well it meshes with the piston body. Some piston bodies have half teeth, which would require us to align the gear a certain way. However, we are using straight cut gears, which make use of full width teeth on the piston body. It is when helical gears are used that half-toothed piston bodies are considered. That being the case, the shimming procedure of the sector gear becomes pretty straightforward. I first shim the sector gear just high enough to clear obstacles and prevent rubbing against the spur gear. The obstacle we have to consider is the head of the screw that secures the cutoff lever, which tends to sit higher than the cutoff lever itself. There is a lot of room for shimming on the sector gear. Take care not to give too much height to the gear from below, and keep it as close to the face of the spur gear without them coming into contact. Double check by inspecting the way the gears sit visually, and turn them by hand to feel for any drag. After the bottom has been shimmed, it is just a matter of filling up the void on top. Add shims until you experience drag, then remove a shim or replace with a thinner one if possible to bring back the smoothness of operation. Like the spur gear, you will eventually strike a happy balance. Close up the gearbox shell and install the fasteners. Turn the gears by hand and listen for vibration and chatter. Correct if necessary by adding shims to eliminate chatter and remove shims to smoothen out the spin. The shim job is done after shimming of the sector gear is complete. We have now ensured the best possible mechanical operation of the ICS M4's powertrain, which is the core of every AEG rebuild. With this endeavor completed, it is time to move on to the next video, which will cover the next step in the rebuild process, and that is to restore the electrical trigger circuit. That's it for this video on how I go about shimming the gears on an Airsoft AEG. Check out the description for more info. I hope you enjoyed. Please leave a thumbs up if you did, and consider subscribing for future updates. Feel free to leave your comments down below. Thanks for watching, and I'll see you in the next one. Bye.